Thank you for coming today. Today, I'd like to talk about data visualization. First of all, let me introduce myself. Hi, my name is Eriko. I'm from Nagasaki Prefecture. I worked for a Japanese financial information company as a system engineer, but I didn't coding. I wanted to create service by myself because I decided to join code research. So I love Starbucks. Actually, every Monday morning, I went to Starbucks to buy a coffee because I want to charge energy for a week. So today, I'll give you a demo. So this demo is a little bit related to Starbucks. I hope you enjoy it. This is today's agenda. My talk is divided into 5 parts. First, I'd like to talk about data visualization. Data visualization is a visual representation of a large amount of data and information. If we use data visualization, it is possible to intuitively understand the characteristic of data and easy to find relationship, features, and trends with other data. Data visualization are essential to analyze massive amounts of information and make data-driven decisions. Every industry benefits from understanding data, and so do fields in government, finance, marketing, education, and so on. Data visualization helps us quickly understanding complex patterns of data. Let me give you some examples of data visualization. As you know, GitHub is project management and code versioning system for developers. In GitHub, the number of user commits and the number of pull requests are displayed in green shade of graph, like this. This is one of the data visualization. This is a data set of popular cities in the world regarding time over from 1500 to 2018. The data set is difficult to comprehend, but if you represent the data visually like this, it will be very easy to understand. In addition, if you use data visualization, a bunch of geographic data can be expressed visually and clearly like this. This sample uses a library called DexGL. When we use DexGL, we can generate a beautiful visualization of graphic and timeline data. There are many libraries for data visualization. I'd like to share a few libraries. First, D3.js. D3.js is one of the popular JavaScript library for data visualization. It has a great community support. It used to manipulate elements of a web page in the context of the dataset. Next is a Chat.js. Chat.js is also a famous JavaScript library for data visualization. Although less flexible and capable than D3.js, but it's lightweight and easier to get started with. This is a DexGL. DexGL is also a JavaScript library for data visualization, specialized in the representation of geographic data. When I first saw DexGL, I was impressed by the beauty of its appearance. Today, I'd like to talk about this library. and explore the data visualization world with you. So, let's move on to talking about DeckGL. DeckGL is created by Uber. First, I'd like to talk about Uber. Uber created an offshore data visualization team in 2015. Uber collects data from many drivers from every day and analyze this data in various ways. They have an engineer blog. If you are interested in, please check it out. This is an example of data visualization of Uber. Do you know Uber Pool? Uber Pool is a share ride that allows you to split the cost of your ride with a stranger. Uber uses data visualization to investigate the impact of Uber Pool on San Francisco. The image of left is before Uber Pool. The bright colors indicate that it is crowded. The image on the right is after Uber Pool. As you can see, there is not as many bright colors. Traffic congestion decreases over time. So it is easy to understand to look like Uber Pool working. By visualization data in this way, large amounts of data can be expressed in an easy to understand way. The data visualization team created DeckGL in 2016. It's an open source data visualization library specialized in the representation of geographic data. It helps us to visualize in 3D and allows us to express complex data quickly and smoothly. Next, I'll talk about technology. This library is written in JavaScript. It is a great match with React, supporting efficient WebGL, rendering under the reactive programming paradigm. If we use DeckGL, it needs to combine with map component, like a Google Map and Mapbox. When we use DeckGL, we have to input the following datasets. Of course, latitude and longitude need to visualize the data on the map. If we express timeline on the map with animation, it needs to timestamp data. So this is an example. It is not use map component like a Google Map. It's just rendering of dataset on browser. It's beautiful, but a little bit difficult to understand because there's no map data. But if we combine with map data, it's beautiful more than before one. But data visualization uses a large data set. Many web developers face the problem with how to render large data efficiently. JavaScript is single-thread event loop model. It is not suited to handle large amounts of data and render 3D graphics. But it is used WebGL. We can overcome this problem. It provides access to the GPU on the user's computer asynchronously. In short, this means all of the heavy works moved off the browser to the hardware. We can handle many data points fast. So DeckGL uses WebGL. Next, I'll talk about layer. Layer is one of the core functions of DeckGL. layer render each data on the map by position, color, 3D. If you use layer, you can also hover and click on the map. So there are many types of data layer in the DexGL. I would like to introduce some of the layers. So first, this is a line layer. Line layer renders line connecting source specified as latitude, longitude coordinates. Next is the icon layer. Icon layer renders raster icons at given coordinate. This is a hexagon layer. Hexagon layer renders a hexagon heat map based on the array of points. The color and height of the hexagon is scaled by number of points in coordinates. This layer renders animated paths using timeline data. It's so beautiful. This layer is one of my favorite layers. Okay, let's go to my demo part. So I'll show you my Starbucks timeline using DexGL. So this is my dataset. In February of this year, I went to Seattle to go to Starbucks. So I used this traceability data of my trip. So from using Google Map timeline data. Next dataset is Starbucks store location data from Kaggle. And my demo used these layers. First is trip layer with traceability of map trip. And second is icon layer used with Starbucks store location. But before demo, let me introduce Starbucks a little. In Seattle, there are 3 special Starbucks stores. So first is headquarters of Starbucks. In headquarters, there are very beautiful Starbucks. So looks like Starbucks. Yes. Second is the first Starbucks in the world. So this is the first Starbucks shop. Third is the Reserve Roastery. Reserve Roastery is very special Starbucks. They roasted coffee bean in this store. You can drink freshly roasted coffee. So this is a map in Seattle. From now, I'll show you my Starbucks journey in February with DexGL. Okay. Yes, this is a map of Seattle. So green star is Starbucks location data. So this is time. And this green line is my traceability. Yes. So actually this is a headquarters of Starbucks. And so I will zoom in. Yes. So this is a Pike Place Street Market and a fire store and a Reserve store. So I just go the only Starbucks. So it's yes, it's 3 p.m. So I go to first headquarters and go to another Starbucks and the first Starbucks. So I went to so many Starbucks. So Seattle is perfect. Yeah. Thank you. So I go back to my presentation. Okay. So how to download my Google Map timeline data? So it's very easy. Go to Google Map and click this your timeline button. After click move to this page, it's just click this icon. You can download your own timeline data. That's it. But First, you should allow Google to correct your location information so that Google can make your timeline data. And this is a Google Map timeline data. So there are many data included in dataset, but I use only these three data: timestamp, and longitude, and latitude. Second data is Starbucks location dataset. So this is a Kaggle page, and there are many types of data, but I use only this data, longitude and latitude of Starbucks stores. Yes, I published this demo's code on my GitHub. So if you are interested in it, please check it out. So you can check your smartphone or your laptop. Yes, thank you. So title is my Starbucks journey. Yeah. Thank you. So in conclusion, what is a data visualization? So data visualization is a visual representation of a large amount of data. If we use data visualization, it is easy understanding of bunch of data. What is DeckGL? So DeckGL is created by Uber. And it is for data visualization of library, JavaScript library. Why we use DeckGL? Because it is open source and process large amount of data quickly and realize visualization of data very beautiful and easily. How to use DeckGL? First, prepare for your geographic dataset. Second, select the layer. And finally, let's combine dataset with DeckGL. In the future, I want to visualize data using another visualization library. So there are many other data visualization libraries in the world. I want to visualize various data using them. So thank you for listening my tech talk. So if you have any questions, please feel free to ask me. And you can watch my Starbucks journey on your smartphone. So this is a QR code. Before QR code is my GitHub page, but this is my Starbucks journey's QR code. Please check it out. Thank you.
Okay, thank you, Eriko, for the awesome journey. I know I really want some coffee. So just to remind you guys,
Okay. All right, so thank you for coming, everyone. My name is Daniel, and I will be discussing C++ and how this relates to music. So how I got into this, I am originally a singer and music producer, so I've been doing singing for a while, since I was in high school. I recently started doing music producing as well. I really like it. I wanted to kind of branch out as a singer. I wanted to be able to write songs myself as well. And so that's how I kind of got into that world. So I do post stuff on YouTube. I'm a singer. I like to post covers on there. I also put some original songs. And previously I also was a voice teacher and SAT teacher, so I have some experience in other things too. So how I kind of got interested in how programming applies to music was when I was doing pitch correction. So nowadays pitch correction is used pretty ubiquitously in the music industry. And it wasn't always that way. It was something that's pretty recent, maybe about 20 years ago it became really popular. And so we're going to talk about that a little bit later, how that kind of works. But first, I kind of want to give you guys an introduction to what C++ is. So is anyone here familiar with C++? Right, cool. C++ is pretty ubiquitous in the industry. It's used for a lot of different everything pretty much. Like a lot of programs will be written in C++, programming languages will be based in C++. For example, we have Adobe. A lot of the products have been written in C++. Maya, which is something that 3D animators and people who do 3D graphics use a lot. Even Apple products use C++, Google Chrome, and pretty much games, desktop apps, it can be used for pretty much anything. It's sort of like a Swiss Army knife of programming languages. So what makes it awesome is that it's pretty powerful. It's very fast because it's compiled, it's statically typed, and it's very scalable. What that means is that as a scalable programming language, we can use it for large projects. We also can have a lot of control over the resources that we use. In C++, we have to allocate memory pretty frequently, which means that we have to know what's going on. We have to know what's going on with memory, we have to know a lot about what's going on with the program, and so we have to have a good understanding of how programming languages work. So, yeah. Okay, so is C++ hard to learn? The easy answer is yes, it's very difficult to learn. The reason being is that there's a lot of syntax that is confusing for people. If anyone's familiar with Python, that's very simple. Like, it's pretty much English when written out. But with C++, there's a lot of things that are going on that we don't really think of intuitively. Okay, so there's a lot of things to keep track of. In C++, we have to work with memory allocation. So is anyone familiar with what that means? All right, yeah. So essentially, we have to, when the computer stores some data, there's always some sort of memory allocation going on. So, you know, we have to think about what's going on with that. For example, when we have, an easy way to think of this is when we have a variable and we want to kind of keep track of that, the easiest way to think of it, we have to store it in some memory address. So what that means is a lot of programming languages will do that for you. You don't necessarily have to do it yourself. But in C++, a lot of times we do have to be careful with how we allocate the memory. So another thing that's related to that is pointers. So pointers are things that maybe variables you can think of that point to certain addresses in the memory. This is how we can access certain objects in the memory, and that is essential to understanding C++. There's also consistent typing, which means that if you declare a variable as an integer or a string, you have to keep using it as that. In things like Python or JavaScript, you can reassign things pretty easily. That's not the case in C++. There's also data structures. So in JavaScript, we have something like the JavaScript object, which is underneath it. It's implemented as a hash map. So it's pretty easy. It's really easy to use, but in C++ you have to kind of understand how to make a hash map yourself and how they work. Okay, so what does this have to do with music? So with C++, because it's a powerful language, it is used in a lot of different fields to do things that are resource heavy. When it comes to music, especially as like a pitch correction app, you would need to make sure that whatever you're doing is done quickly and resourcefully. All right. It's also fun because when you think of these topics, you know, the music industry is kind of mystical to a lot of people. They don't really understand how it works. Things like pitch correction is something that a lot of people just kind of know as like auto-tune. And auto-tune in and of itself is very complicated, but a lot of people don't really understand how it works. Okay, so I wanted to kind of cover like what a basic program would look like in C++. So in C++, we have to have our main function. This is necessary for writing the program generally. So what that looks like is we usually set it as an integer, and we return 0. So why we do that is because that allows us to tell the program when it hasn't run successfully. If it returns 0, we know that the program has been executed successfully. Otherwise, it can mean an error. It really depends. This is just a general overview of that. And the program will always execute from main. So when you write your program, you have to make sure that you write what you need in main. Okay, so a pointer, as I mentioned earlier, is a variable that points to a variables that point to a variable's in-memory address. Can be like a lot of different things. So in this example, I have an integer foo that is set to 5, equal to 5. I have this pointer. So the pointer is it's referenced using the asterisk here. So when I output that, we get 5. Foo is 5. When I output the memory address, so the asterisk here, it's something that dereferences an address. What that means is that we are going to get whatever is stored at that address. So I output that, and it gives us 5 as well. Okay, so let's see who's been paying attention. What will the first thing here output number? Anyone have any ideas? 10. Yeah, awesome. How about the second one? This one's a little bit tricky. You don't have to know the exact thing. Just yeah, good job. And the last one? 10. Yeah, awesome job. Okay, so memory allocation in C++, it kind of looks like this. Like when we have an array, this is like a standard C array. We have 5 blocks of memory here, and each of these things are being allocated to that block of memory. So the array size here is static. What that means is that if we set it as 5, it has to be 5. We cannot, like in JavaScript we have push, you can't do that. Like a list in Python you can append, you can't do that here. What you can do though is resize the array. So let's say that we wanted to make an array of size 10. I have an example here. It's a little bit complicated for the sake of demonstrating it, but essentially what I'm doing here is I'm like, okay, I'm going to resize the array. I'm going to say it has 10. The next things are copying the first 5 elements of this array into the second one. So I copy the first 5 elements, and then I add what I want into the last 5. So that's some way you could resize the array. And I wanted to cover one more thing that was really helpful as someone who is experienced with JavaScript. I came across this thing called an unordered map in C++. It's pretty similar. You have to import it, sort of. And internally, it's implemented as a hash table. It's helpful for JS developers when they're learning C++. So if you are really familiar with JavaScript and you wanted to do C++, you could try doing this. There's a few caveats though. You have to use a pointer sometimes, which is very complicated if you're new to the language. So a simple implementation could be like you have your name and then you have someone's phone number. All right, so here, for example, I have an unordered map. I'm going to say the unordered map here, it has a key value of an integer, and the value here is going to be an integer as well. So we have to denote whether or not it's going to be an integer, a string, etc. The second one here has a key of an integer and a string for the value, and the last one has a string and a string. So does anyone have any ideas what we would? Does anyone know what the this would output? Foo 0, anyone?
1.
Good job. How about var 1?
Hello.
Yeah, and the last one?
Hello.
Yeah, awesome. Okay. Okay, so now we're gonna move on to some of the more difficult stuff. Okay, so I'm gonna talk a little bit about pitch correction again. So why this is used is it's an industry standard. It allows for higher quality songs. We also want to have more efficiency. So as a singer, if you're in the studio and you don't hit the note right, you might have to keep doing it over and over and over again. That would really tire you out. And also, when you're trying to sell stuff to make money, you can't be in the studio all day singing some note over and over again because you don't like how it sounds. So pitch correction really helps streamline the process for a lot of singers. And it sounds great. I know people don't like it sometimes, but if it's done correctly, as in not overly auto-tuned, it can really make you sound a lot better. And also add some complexity to a song. We can do a lot of things by pitch correcting. We can create harmonies. We can do. We can also create a duet, and it also helps blend the sound. So when you're creating a song in a digital audio workstation, we want to make sure that we are blending everything together, and when we're able to correct the pitch, it can really help us blend with the instrumental in the background. Okay, so I want to kind of help people understand the theory behind this. So, we have something called pitch. That's the frequency, and that's measured in hertz. So, for example, on the next slide, I actually give an example of this. So on the key, it determines which notes a singer is allowed to hit. So for example, if we have a song in C major, we can only hit C, D, E, F, G, A, B, C. So what that means for pitch correction is we know what frequencies the singer can hit. That helps us kind of push the note to the correct pitch. And lastly, people tend to think of scientific pitch notation to help them with things with abstracting frequencies into octaves. So some example of this is we have our frequency, that's 440 hertz, and that's A4, so that means A in the fourth octave. And A3 would be half of that, and A5 is twice that. And that just shows on the going up. Okay, and some history of autotune. Autotune was actually invented by Dr. Andy Hildebrand. He was an oil industry researcher. So originally, the algorithm behind it was used to help oil companies find subsurface maps to find potential drill sites. So and funnily enough, in 1996, he used it to pitch correct music, which actually ended up being a bigger deal for people. It was a lot more influential, which is kind of interesting when you think about it. And Cher famously used it in her song Believe. Does anyone know that song? Yeah, don't age yourself. Nowadays, it's used ubiquitously in the music industry. And by autotune, so I just want to correct something about autotune. Autotune itself isn't usually used by professional producers. It's very robotic sound. So the way they will use pitch correction, I use a software called Melodyne by Salamoni. It gives you the an interface, and you can change each note at a very, very minor level, so you can barely even tell that you're correcting it until you listen to it. That's pretty cool. I recommend. Okay, so how do we detect pitch? So for a fast transform, does anyone know what this is? Yeah, a lot of people say they do, and it's a lot of it's a lot. But I'll try to kind of get a little basic here. So essentially, it's with the Fourier fast transform, we want to take a smoothie, and we want to get the ingredients. So we're taking say for example, you have a smoothie, and you want to find out what each ingredient is. That's essentially what it's doing, except it's very complicated, but more complicated than that. So for example, we have a filter for bananas. We'll see, okay, the banana is 1 ounce. We have a filter for milk. We'll see that's 3 ounces, and so on. Okay, so some of the signal processing basics. So a digital music signal changes value over time. That is stored like a sequence of numbers. Is anyone kind of familiar with this at all? The larger the number means it has a greater amplitude. So if you see here, it's bigger, that means it's louder. As if anyone's familiar with the waves on SoundCloud or something, you can see when it's bigger or not. The sequence is periodic if it repeats. The length of this section is called a period. And the frequency is measured as 1 over period. That's in hertz. This is what means cycles per second, if that's easier to think about. And a high frequency means a high pitch. A low frequency means a low pitch. Okay, so if you wanted to look at it as a graph, this is just a regular like wave here. We can see that it has a frequency of 1. So if you see like this is plotted against time, we can get the frequency very easily. So it really helps us distill things into very small amounts that we can kind of break down. Here, this looks complicated, but when we break it down, we can see that the two frequencies here are right here. We can see the magnitude of each frequency. And here, this looks simple, but actually it's more complicated. So you can see how it can be useful for very complex waves. Okay, so does anyone have any questions so far? No? Okay. All right, so pitch detection. So there's two parts when you're creating some sort of pitch correction software. The first thing you want to be able to do is detect the pitch. That's very important, obviously. So what they use is something called a short time Fourier transform. 1 hertz is played for 1 second, and then, so in this example, we want to say that if 1 hertz is played for 1 second and 10 hertz is played for 5 seconds. So normally, we would only know that in the span of 6 seconds, we had 1 hertz and 10 hertz. We wouldn't know in which part they were played. What this will do is it breaks things into 6 windows for each second. So let's say we want to know, okay, first second, 1 hertz played, the last 5 seconds, 10 hertz played. So that's very helpful. And it's usually represented by a spectrogram, some examples here. Okay, and this is Melodyne, by the way. So it's the pitch correction app I was mentioning earlier. So with pitch correction, we can find the pitch using the previous method first. After that, the singer will sing the fundamental frequency. So anyone know what fundamental frequency is? All right, yeah. It's when you sing a note, or when a note, any kind of note is played, there's many like harmonics, so a lot of different frequencies being played at the same time. The fundamental frequency is what sound is heard. So when I first learned that, it was kind of mind-blowing. Like to know when you first go over, when I first learned singing, you kind of know, okay, I have to hit the right note. I like have to sing the right pitch, and like that's it. Actually, when I found out that there's multiple frequencies always being heard, you just like and it actually affects the sound. I was pretty mind blown by that. So yeah, you detect the fundamental frequency, and then a sound from a singer is often filled with random noise too. So you kind of have to account for that. So how the pitch correction works itself is it's through time scale modification. That means that they will like double the frequency and then halve the period by doing so. But when the period is halved, the signal loses like half of the time. So it's like you have to really accommodate for that. And yeah, so I wanted to mention one more thing about pitch correction. So there is in Melodyne, there's something also called the phase shift. So one thing that happens when you have like a note that is you sing into a microphone, for example, it will have vibrato, if anyone is familiar with that. So you can be singing and it'll be like vibrating, if anyone's familiar with that in a singer's voice. So how we can kind of accommodate that is in Melodyne, it will even detect the minor changes in the frequency there, and then you can either just like stress that out, so you can make your vibrato sound longer or make it shorter. So one of the things that I found very fascinating when I was using this was being able to understand how to shift that. And it's actually pretty amazing what you can do. You can make yourself sound like, if you don't even like vibrato, you can make it longer or you can make it shorter. And it's, in some ways, some people have a lot to say about that. Like, some people think, oh, like, you know, you shouldn't be allowed to alter someone's voice in such a way. But I think nowadays people are coming to accept pitch correction as an essential part of the industry. And so as time goes on, we will even see people are trying to artificially create voice. So if you've seen, like, anyone know Hatsune, what's the Vocaloid. I'm really curious to see how this will change in the future, if people will be able to augment or just completely create voice from software. And so that's pretty much what I have to have you guys today. If you have any questions, just come ask me. Yeah. Thank you.
Good afternoon, everyone. My name is Waldemar Ishibashi. I'm originally from Poland. I graduated from Poland with a civil engineering degree. After that, I went to London, where I was a civil engineer working for London Underground. I was building the new metro project. I was always interested in IT. I was always connected to that. I was always trying to force it on my bosses to use the newest technology ever. And at the same time, I met my wife, who's Japanese, and after we got married, we decided to start our life in here with her family. The goals of my presentation. This is a really brief lecture about machine learning. It's sort of like an initial phase entrance. There is some information on the slide that's sort of advanced, and the reason for that is I assume some people will look at it again when they have tiny bit more knowledge, so they can go and research tiny bit more. And I also want to show the road I've taken to learn tiny bit more machine learning. What is machine learning? Well, it's a field of study that gives computers the ability to learn without being explicitly programmed. So the big difference is normally when we design software, we provide the rules and the data, and then our program has pretty much the only way to work, and then we get an answer. Where with machine learning, we provide the answers and the data, sometimes only the data, and then through our machine learning, we get the results. There are three main ways we can categorize machine learning. So the first one is supervised, second one is unsupervised, and there is reinforced learning. The supervised is where we provide both the data and the answer for that data. So the model is constantly checking whether the calculation is right every time it calculates it. And then unsupervised, the answer is not the reason we do unsupervised learning is to divide the data into certain features. So let's say we have our customers, we want to know which one bought something from us, which one didn't. It's not a scale, it's just whether it's a yes or no, whether it's a cat or a dog. It doesn't have to be two, it can be multiple different types of data. That if we feed enough data, the algorithm will learn which type it's looking at. And then reinforcement is actually quite advanced subject, and it's a combination of unsupervised and supervised. Another type of division is regression, classification, and dimensionality reduction. Regression is where we feed the data and we get the results. So let's say a perfect example would be a stock market. We have all the data from a stock market and we want to predict the price. Let's say, what's the price in 5 minutes? So then we can do our real life trading. Or if we feed in photos, we can ask the algorithm what's the age of the person with what prediction. Where with classification, we, as I said, we just get what type of data we're looking at, whether our client is likely to buy from us or not. Or let's say whether for medical data, it's often when we check the blood and we know that the person has a cancer, from all other data we have about the patient, we can predict which type of cancer it is. This is where it's used for. And then dimensional reduction is the whole bunch of machine learning algorithms that help prepare the model for further machine learning. Like checking from photos. Like let's say we have a bunch of photos mixed from the internet. We want to recognize the face to do further operations on those faces to check what type of face it is. So this is where the dimensional reduction functions comes in. Machine learning flow. But first, obviously, we need to train the data. So usually from the whole data we get, we take around 80 to 90% of data to our training. We train our model, and every now and again we validate our model to check which works. And it's all from a first bunch of samples. because with machine learning, different models work with different accuracy. So we need to validate that data while retraining the model. This is where engineers come over to fiddle that model to check what is perfect. And then testing the model doesn't change the model anymore. It's literally the last stop before giving the model to the client for us to check whether we've done a good job or not with our model. Data effectiveness. That is very crucial in machine learning because the model learns on our data. There's something called underfitting bias, which is a perfect example is the stock market. If we provide only a few models and we want to predict it for a week in advance, obviously not going to do a good job. And then overfitting happens when we provide too much data and then the models start start finding patterns that do not exist there. So then the results will be not realistic. So that would be an example of reality, which is just two groups of samples. The good model will obviously never be perfect as a reality, but our model will figure out the division somewhere here. And if we provide the data with too much bias or too much noise, the model may start struggling. Also, our model is not a perfect example. It doesn't have to be perfect example of reality. For example, for Gmail and spam, for their model, they don't have a real life balance between spam and real mail, because then the model will struggle to learn. So they overfeed the spam, let's say 20 times. So the model learns exactly what spam is, how important spam is, and then if every now and again the model will think, oh, this is spam by, it's not a big problem. Bigger problem is if it's not spam by, it is spam. Also a more risky scenario is recognizing cancer. We giving the model a real life scenario where we want to predict the cancer. We need to really think about what the goal of our model is. With cancer, if we get too many false positive, there's not a big problem because we can do further tests and we can say, okay, our model didn't predict it appropriately, but we know our patient doesn't have a cancer. The bigger problem is if our model will be very sure that that person from that data doesn't have a cancer, but in reality it has a cancer. So the model and the preparation of the model and the understanding of the model is really important to create a good model that works in real life. That's, I think everyone possibly knows that picture. That's a simplest neural network with just 3 inputs, 1 hidden layer and one output. We call these neurons, and they're not exactly human neurons. These are the ones that calculate the little functions, and the input is types of different functions. Deep learning is something that comes up in pretty much every article. The only difference between neural network and what people call deep learning is the addition of a hidden layer that adds complexity to the model. So with the same functions that we're feeding, we can get a completely different way of thinking of the model. As the website I wanted to show, this is made by Google. That's the address of the website, and the information will be provided further on. I've spent, I think, 4 hours on that website to understand what a neural network is. The reason for that is because it's visual. And I want to also explain how a neural network works tiny bit on it. So this is a play button. Obviously, the epoch is the amount of rounds that the neural network does explanation. For a model, we can add a learning rate. The faster the model learns, usually the worse the result is. The slower it is, it can overfit, so it can find things that don't exist in our model. So there is a balance between all of that. And on a beautiful website, we feed our data, which in that case is in there. So our data is just recognizing which dots are where. So our orange dots are outside, our blue dots are inside. We can feed features, which is what functions our model fits, how many hidden layers we have, and how many neurons we have. If someone wants to really visualize how neural networks and machine learning works, this is the first website I would suggest to play around with. And it's good to learn also how a model learns when we add certain stuff, because I used to think when I start, the more complicated, the bigger the model, the cooler it is obviously, and also the better it works, which is not exactly how it works. Sometimes with only one model, we get really good results. So if you see in here, it's 6 epochs, which is 600 times the function has to go through. With just one added, one neuron added, it's 200, and the results are really good. And this is an example where if you fit if you make your model too complicated, the answers may not come up, because the model will try to find something that doesn't work doesn't even exist in reality. So strongly advise to play around with that website. And then for that model, this is a perfect spot. It learns really quickly and efficiently. And if we make it too simple, it doesn't learn. And also, what I was thinking before when I was learning, so I was thinking, how is that the model knows what's a good answer? So the good answer is in weights. If the function creates an appropriate answer, these weights will go heavier, which is they go bigger, which is the way machine learning works. It tells the model what you're doing is right, so what this one is doing is right, what this one is doing is wrong, do more of what's right. And that will be an example of machine learning hello world. And the point of that is to figure out the function, why we need to get appropriate, to figure out the function. I will explain it later on. So when we feed x -1, we want to get -3. So how do we do that? How do we do it without having the function itself? Well, originally, normally what people would do is take -1 and okay, we need to get -3. So what's the y? So the y in that example would be possibly 1.3, because it fits the model. And then we go, okay, it's -3, we go to our next example. If we fit -3, it doesn't really work for this one. So this is where our weight comes in. We go back and say, okay, this is not exactly how it is. Let's continue further on learning. If we fit 0, we're getting -1. So what does it mean? Well, it means the -1 is possibly 0 plus something. So that plus something will be, in this case, -1. So now we know to get a y, we need to do something with an x and then take -1 of it. And we're going to get our answer with reasonably good prediction. So if we go further, we get 1 and 1. So how do we do? Well, we have more data because we already did some calculations. So if we take our y, which is 1, and then we have an x, and we're getting -1, which eventually results in our x equals 2. So eventually we can figure out that y is 2x minus 1. And the crucial lesson from that is, for me to figure that out, I need to take my first example, -1 and -3, do some calculations, check how it works, and then go back. And then further continue doing my process. And I'm literally learning, and this is where machine learning comes in. The machine learning does one prediction and then goes back, takes further data, and then do another prediction. And then as they go along, if a model is done correctly, we get a model that can predict within reasonable accuracy how good our model is. and that's how it looks like in Python. We import TensorFlow to Python, and we import NumPy, which does operations, and then we create a model, which is one neural network, one layer with one neural network. We feed our data, and I have additional data to make it way quicker. And the magic happens here, and we're literally fitting our data to our answers. We're squishing them back together, and then our model trains itself pretty much, and we're just giving the answers. And that's the links I want you to have. That helped me a lot. There is a lot of information on the internet that's very vague. So this is sort of, if someone does those steps, they can have a nice roadmap of how to learn. And I want you to have also some shortcut to do this Python exercise, because actually, if someone never did Python, that takes quite a long time to set everything up. So that's just for you for the future. And this should be my last. And that's the end of my presentation. I'm not sure why it doesn't load right now. Thank you very much.
Okay, thank you so much, Badu, and we'll figure out why it's not loading and show you the last slide in a bit with all of your contact information.
And I will add the link to that to our YouTube as well. It's literally the information was on the last slide, but it doesn't want to load.
Okay, good job, Badu. Thank you again. Alright, so our next talk is going to start at 3. So again, if you've been in here, I've said this several times, but just in case you're new, there is still a talk going on in front, so feel free to catch the last few minutes. Also, if you go outside, please do try to be a little bit quiet as the talk is still ongoing. So see you again at 3, where we'll be hearing from Diallo.
Alrighty, hello everyone, and hello to people watching on the live stream. Thank you so much for joining us for today's big MiniConf. My name is Diallo Spears, and today I'm going to be giving an introduction to game development in JavaScript. This talk is aimed at people who are JavaScript beginners, so people who have some fundamental coding knowledge under their belt and who are interested in making their own video games, but who have yet to take the plunge. My hope is that today I can show you that the process of creating your own game is maybe not as scary as you have feared. So the agenda for today's talk is, first I'm going to give a brief self-introduction. I'm going to talk about my background with coding and my background with video games. Then I'm going to explain why you should consider making a game in JavaScript of all languages. After that, I'm going to give a brief demonstration of a game that I made, and then finally, I'm going to use that game as an example to explain what the core components of game development are and what you need to do those in JavaScript. So without further ado, once again, my name is Diallo Spears. My handle is @followdiallo. You can find me on GitHub, and also I just made a Twitter, so I'm on Twitter now too. Before joining Code Chrysalis, I worked for 3 years as a Japanese and English translator/interpreter. This next point should come as no surprise since I'm giving a talk about video games, but I'm pretty into video games. Since moving to Tokyo, I've been relatively involved with the indie game scene here, so I go to a lot of game-related events, especially events for game localization. As for my background with coding, I began seriously studying coding this year in March, so still less than a year of experience. With that being said, I've made 2 games in JavaScript to date. So if someone who is as new to coding as I am can make a game in JavaScript, then you definitely can as well. Okay, so why do I think you should make a game in JavaScript? So if you've looked into making your own video games, you've probably seen recommendations for languages like C++, Java, or Python. Or you may have seen people recommend that you use an engine such as Unity. JavaScript, on the other hand, is not particularly well known for being a video game language. So why do I think that JavaScript is a good starting point? Well, for starters, JavaScript is more beginner-friendly than languages like C++. JavaScript is one of the most popular languages out there. In fact, at one point, JavaScript was the most popular language on Stack Overflow. So there are a lot of people out there who are choosing JavaScript as their first programming language. C++, on the other hand, is notoriously difficult for beginners to learn. So if you're a person who chose JavaScript as your first programming language and you're interested in making games, don't think that this is something that's out of reach for you just because you started with JavaScript. The next point is that there are no special libraries or frameworks required to make a game in JavaScript. Of course, there are plenty out there that you can use if you so choose, but to get a basic game up and running, all you need is pure JavaScript and a little bit of HTML. Next is that if you are a JavaScript beginner and you're still getting a hang for object-oriented programming, making a video game is a really good way to practice that. And I'll explain explain why a bit more later. The next point goes for any programming language, not just JavaScript, but setting measurable goals is a really good way to learn. So if you've done some introductory coding and then you're looking to increase your skills, one of the biggest pieces of advice here is that you should practice making your own projects. And I think that a video game is a really good first project to work on and something really concrete that you can work towards. And then last but not least, you can create some really cool games in JavaScript. So let me show you some examples. All right, has anyone here heard of a little game called Angry Birds? Yeah, super famous game. Fun fact, this is actually written in JavaScript. And the next game was not originally made in JavaScript, but I went to a presentation earlier this month where the presenter explained how he was able to recreate Super Mario Brothers using JavaScript. So this goes to show you that you can still create some really cool games in JavaScript. Alright, so now that you've decided to make a game, the next step is to create a sort of game plan, no pun intended. So the first question you need to ask yourself is, what kind of game do I want to make? And this might seem like a fairly obvious question, but the reason that you need to ask it is because depending on the type of game you want to make, your process for creating the game is going to be very different. So creating an action game is going to be very different than creating a puzzle game, which is going to be very different than making a racing game. So you need to decide what kind of game you want to make first, and then you'll be able to work in that direction. And then after you've decided the direction you want to go, my next piece of advice for you is to start small and then expand upon that. So you might have an idea for several characters you want to create, or several power-ups you want to include, or several levels that you want to have in your game. But if you try to implement everything at once, it's going to be very overwhelming. So I would say identify what the core areas are that you need to have your game up and running, then start from there, and then once you have that down, you can add to it. So when I was thinking of what I wanted to do for my first game, I knew I wanted it to be some sort of 2D arcade-style game. And in terms of inspiration, I decided I wanted to try to recreate a game from my childhood. So did anyone here play Neopets back in the day? Did anyone remember this game, Jelly Blobs of Doom? Well, I decided I wanted to try to recreate a simplified version of this game, Jelly Blobs of Doom. So let me show you what I did. Alright. Okay, so this is my game. I'm controlling this little white square. I have to avoid the squares that are larger than me. If I collide with one of those squares, it's going to be a game over. But I can also run into the squares that are smaller than me, and if I do that, then I will get some points added to my score in the top right corner. And you might have noticed that my square expanded a little bit. So the more of the smaller squares I eat, the larger my square is going to be, and then the larger squares I can eat. So they're moving really fast, so let me try to catch this guy. Alright, you can see my square got a little bit bigger. And then if I hit this square, oh, it's game over. Another thing to note is that the squares are being randomly generated with a random starting position, a random direction, and a random speed and color. And I'm using the arrow keys to control my character right now. So that's the basic idea of my game. So now let's break that down and identify what exactly are the core components of that game. So for starters, we'll need some sort of 2D game space, some area to render our game. We'll also need to have some sort of player character. So in that game, that would be the white square that I was controlling. We'll need to have some sort of obstacles, so the pink and purple blocks that were flying around the screen. Then we'll need to have some behavior where if my player character interacts with a smaller block, then he can eat that block. And then the opposite, where if my player hits a block that's larger than him, then he disappears and we get a game over. So without further ado, let's look at what the code for that will look like. So the first element that we're going to talk about is the canvas. As the name suggests, this is literally the canvas for our game. So everything that's happening in our game will be represented on this canvas. In terms of code, what the canvas is, it's an HTML5 element, and we're going to give it 3 properties: ID, width, and height. The width and the height are fairly self-explanatory. They're how wide and how tall we want our object to be. One thing to note is that you might see, we have it defined inline right here, and you might think, okay, I'm not going to define it inline, I'll define it in CSS instead. Well, the HTML height and width properties are slightly different than the CSS height and width properties. So it's best to define it inline, otherwise things will not line up exactly how you expect them to. And then the ID is just sort of a nickname we can give to our canvas so that we're able to refer to it later in our JavaScript file. And then one other thing I would recommend for you is that you give your canvas some sort of border or background color for visibility so that you can make sure that it's appearing as you expect it to. Okay, so now that we've created our canvas in the HTML file, when we want to refer to it in JavaScript, we will do it like so. So we'll first create an element called a variable called canvas, and we'll set that equal to document.getElementById, and then whatever ID we gave our canvas. So in my case, I called it canvas, so I'm doing document.getElementById canvas. And then the next thing we have to do is define that we're working with a 2D game space, and for that we'll need something called context. So we'll create a variable called context, or CTX for short, and we'll set that equal to canvas.getContext and 2D. Alright, now that we have our canvas, there's a lot of different ways that we can make things appear on the canvas, that we can draw on this canvas. So we can draw basic shapes like squares or circles, triangles, lines. We can also have some text appear on our canvas, and we can even include images either from our computer or from the internet. These are some examples of some of the methods that we can use to start drawing on our canvas. So let's take a look at one of them in action. So in my game, everything is a square. The player character is a square and all of the obstacles are squares. So let's talk about how we can draw a square on the canvas. So to draw a square, we're going to use a function called fillRect, just short for fill rectangle, which takes 4 arguments: position x, which is the position on the x-axis, position y, which is on the y-axis, and then width and height. So the top left corner of our canvas has coordinates 0, 0, so x is equal to 0 and y is equal to 0. And the farther to the right we go, the higher the x value increases, and the farther down the canvas we go, the more the y value increases. So by defining the position x and the position y, we can say exactly where on our canvas we'll want our square to appear. And then again, the width and the height are the width and the height of the square. So, for example, if I wanted to make a square, and I wanted it to appear 50 pixels to the right, and 150 pixels down, and I want it to be 200 by 200 pixels wide, then I would call fill rectangle with the arguments like so. One other thing to note is that the default fill style for this function is black, but if you want your square to have a different color or maybe a pattern or a gradient, you can define that using another function called fill style, which takes a color as an argument. So if, for instance, I want to create a red square, then before I call this fill rect function, I will call fill style and pass it red as an argument, and then as a result, what we have is this. We have our canvas, and we have our 200 by 200 square, exactly where we want it to be. So yeah, we've drawn our very first thing on the canvas. Alright, now let's say that I want to update its position. So instead of having it to be 50 pixels to the right and 150 down, I want it to be 150 to the right and also 150 down. So you would think that I should be able to just call this function again and give it the new coordinates. But when I do that, let's look at what happens. Okay, so instead of seeing a square like we expect to, we're seeing a sort of elongated rectangle right now. And the reason for this is because, so this is what we were expecting to see. But the reason that we're still seeing this is that we're seeing an elongated rectangle like this is because when you draw things on the canvas, they remain there. So we drew our original square, and so that's still there, and the new square has been drawn on top of that. So we have a little bit of a problem. Fortunately, there's a function we can use called clear rectangle, which will let us clear the canvas. So this takes the same arguments that the fill rectangle function does. So every time we want to update the position of the rectangle, we'll have to first draw it, and then clear the canvas, then draw it again, and then clear the canvas again. And this is going to give us the illusion of movement. And so this is a very repetitive cycle, which brings me to the next thing that I want to talk about, which is something that's very fundamental to video game programming, which is called the game loop. So as your game is running, you're executing certain actions over and over and over again. Lots of updates and lots of redrawings. So in this case, the main components of our game loop are going to be a step that clears the canvas, then a step that updates all of the information of everything that's on the canvas, and then finally redrawing everything according to its new information. And again, we're going to be repeating this over and over and over and over again. What allows us to make this process repetitive is a built-in function in JavaScript called requestAnimationFrame, and this function is essentially asking the browser, please reanimate me again as soon as possible. So we'll create a game loop function that will have these three steps, the clearing step, the updating step, and the redrawing step. And then at the very end of that game loop function, we're going to call requestAnimationFrame, and we're going to pass it the entire game loop function as an argument. So we have some recursion going on in there. Okay, so now that we've set our canvas and we have our game loop up and running, let's talk about actually putting some things in our game. I mentioned at the beginning of this talk that if you want more practice with object-oriented programming, video games are a good way to do that. And the reason why is because basically everything in your game is going to be its own class. So to give some examples, in the game that I showed you, the player is its own class called player. So the little white square is its own class. And then all of the obstacles were their own class. And then often it's helpful if you make your entire game into a class and then have your player and obstacle classes live inside of that class. And then when you have your classes, you can give them some properties that are going to define their characteristics, be that size or color. And then you're also going to give them some methods that will define their behaviors. So let's take a concrete look at a specific example. Let's start off by making a player class. So what are some basic properties that we might want our player class to have? So the little white square in the game that I showed you. Well, for starters, we'll probably want to give it some sort of size. So we'll give it properties width and height. And then we also probably want to give it a position, so somewhere to appear on the canvas. So that could be represented as a set of x and y coordinates, like so. So these are some bare bones properties, and let's see what that would look like in our game world. Okay, so right here we have a 40 by 40 square, which is what we want it to be in terms of size, and it's right now at 0, 0, which is where we told it to be. And you can see on the bottom right of the canvas, I'm representing the x and the y values of the player's position property. So let's say that we want to make this more dynamic now, and we want to have our player character move around. What do we need to do to the player character in order to get it to move? So let's say I want to move it to the right. you can see the farther to the right I go, the more the x value is increasing. So basically what this means is that if I want to move the player character to somewhere more towards the right, I just need to go and increase its position.x value. And then also if I want to move it more towards the bottom, then again the y value is increasing, so that means that I need to increase the position.y value. And of course the reverse is true for moving it up and for moving it left. Okay, so let's talk about what that looks like in coding terms. So if we can actually encapsulate that behavior that I just talked about in functions. So I can create, if I want to move the player right, I can create a sort of move right function, which every time it's called is going to update the player's position .x value. Or if I want to move it up, for example, I could create a move up function that every time it's called is going to update the position.y value and make it and decrease it. So of course this wouldn't be a game unless we had some way for a human to actually interact with it. So we need to find some way that we can translate the player's behavior, the player's input into actual behavior for the character. And there are many different ways that we can control the character. For example, we could operate the game by pressing buttons on the keyboard. We could click something on the mouse, or we could just move the mouse around. Or we could use more unconventional input methods. For example, we could have a voice-controlled game. But whatever method we decide to use, we're going to need to have some sort of input handler for that. And for that, we'll need some event listeners. So basically, we need to tell our program to listen out for the actions that we want the player to do. And every time the player does that action, it'll fire off whatever behavior we want it to fire off. So to give an example, like I mentioned, in my game, you control the player by using the arrow keys. So every time I press an arrow key, I'm triggering the appropriate movement function that I want to call. So if I press the up arrow key, I'm calling the move up function. If I press the right arrow key, I'm calling the move right function, etc., etc. Okay, so now we've laid a basic framework for our game. We have a player class that has some properties and it's got some methods, and so now we can continue to expand to that. So we started off by giving our player class size properties and position properties, but we could also give it some properties like maybe color, or we could give it a speed. And then we talked about some movement methods like moving left and moving right, but of course you can do more than just move in a game. We could also add something like a jump method to allow our player to jump, or if I'm making sort of an asteroid game, I could create a shoot laser method. Basically any sort of behavior you want to be possible you can create as a method. And then finally, right now we just have a player class, but of course the game's going to be kind of lonely if we just have a single player existing in this game space, so we could create some block classes, any other class we want to add to the game. And then one important thing to note here is that we control our player character by using event handlers, event listeners, and input handlers. But to update the non-player characters, we'll use their update functions. So we'll define some behavior that we want to happen every time our game's updating, and we'll put that in the update function for our non-player characters. And the very last thing that I want to talk about today is adding interaction between the different game elements that we created. And for this, we'll need something called collision detection. So the question we have to ask ourselves here is, what happens when two elements in our game collide? So I'll give you some examples of what it looks like in some other games. So when Mario and a one-up mushroom collide, so when they're both occupying the same space, what happens? Well, the one-up mushroom disappears and then Mario gains another life. Or in Pac-Man, if Pac-Man collides with the power pellet, then all of the ghosts turn blue, and then Pac-Man is able to eat the ghosts when he runs into them. And then with this breakout game, we can also see a couple other examples of collision detection. When the ball collides with the paddle, it bounces off of the paddle, and when the ball collides with the brick, a brick disappears. And if the ball collides with the very bottom of the game screen, then the player loses a life or gets a game over or something. So basically, by defining the rules of our collision detection, we're going to define what exactly is happening in our game. So collision detection works by taking two objects and comparing basically, okay, I'm going to look at the top edge of object A. Is this anywhere within the border of object B? No? Okay, well what about the right side of object A? We're going to check every single side of object A against every single side of object B. And then we'll do the reverse. So we'll check object B and see if any of B is inside of object A. And if we find that they are overlapping, so in this example over here, we can see the bottom of object A is overlapping with object B, so that means that there is a collision. So we'll create some sort of collision detection function that says, okay, if, it'll first calculate, are these two objects overlapping, and then in the case that they are overlapping, it's going to trigger whatever behavior we want it to trigger. Alright, so to give a brief recap of everything that we've covered today. So to begin, we have our canvas, which is the area where our game is being rendered, and there's lots of different methods we could use to draw on the canvas. We have our game loop, which is a cycle of clearing our canvas, updating everything on the canvas, and then redrawing everything on the canvas. We're making everything into our game its own class, so we'll have player classes and non-player classes, and then we'll give those properties and methods that define what's going on with them. And then we'll use collision detection to define what happens when things are interacting in our game, and sort of define our game's behavior. And the last thing that I want to mention is that I've shown an example of how to create one type of game in JavaScript, but of course there are many kinds of games out there, and there are many different ways you can go about doing it. So the possibilities are endless, so I encourage you to explore and play around with things and see what you find out. If you're curious about the game that I showed you today, it's up on GitHub, follow Diallo, and it's called The Square Game, so you can scan this QR code if you want to check it out. I also have another game. I'll let you finish doing that, and then... Alrighty, I also have another game that I didn't get to show today called Infinite Hummer. This is a voice-based infinite runner game, so you actually operate this little green piece by humming like a rising tone or humming a falling tone. It's a little bit similar to Flappy Bird, but voice version. This one's also available on GitHub, so feel free to scan this QR code, and if you play it, please let me know what your high score is. I think right now Vic is the reigning champion with something like 12,000, so see if you can beat him. But yeah, thank you again for coming here today. Once again, my name is Diallo Spears. I'm on GitHub at Follow Diallo, and I'm on LinkedIn at Diallo.Spears. So thank you so much.
Thank you for so much for coming today, Tech Talk. So today I talk about getting started with mixed reality with HoloLens. At first, my name is Naoto Imamachi. My background is pharmaceutical sciences and biology. I researched genomics and gene expression analysis for 6 years in my university. After that, I worked for a diagnostic testing company as a systems engineer for 2 years. My current interest is JavaScript, Java, Golang, AWS, and today's topic, mixed reality, especially Microsoft HoloLens. Yeah. So first, I want to talk about my story, HoloLens and I. When I was a university student, for the first time, I met the HoloLens and mixed reality. I was very impressed with this new technology and HoloLens. So I bought the HoloLens using my old saving in those days. Yeah. So because I can buy the future only $3,000. Yeah. So this picture is HoloLens meetup in Tokyo for the first time. For the first time, I joined the meetup as a hobbyist, not software developer. And this is my story, is the reason why I want to become a software developer now. So today, I introduce what is mixed reality and how to create a setup, development environment, and finally, I show several demos about functionality of HoloLens, such as how to interact with object, virtual object, and voice control to manipulate object, and also what is spatial awareness system in HoloLens. So, first, I want to explain the history of computing. In 19th, the era of personal computing came. Now people use computer for creating a presentation slide or creating a report, something like that. In 2000s, the era of mobile computing came. Nowadays, people use the smartphone in the palm of hand, and we use the computer, mobile computer, such as SNS or web browsing and web shopping, something like that. So after that, I wonder, what is the next computing? So one of the answer is, I think, holographic computing, today's topic, such as virtual reality, augmented reality, and mixed reality. In my talk, actually, the meaning of mixed reality is almost the same the meaning as augmented reality. Actually, the meaning of mixed reality and augmented reality is very controversial. So, in my talk, the same meaning, almost the same meaning. The mixed reality is the result of blending the physical world with digital world. The mixed reality overlay virtual object on the real world. The most popular example is Pokemon Go. Have you ever played Pokemon Go? Oh, many. So, as you can see in that, through the smartphone, we can see the virtual Pokemon on the real world, like that. And there are two options to show the virtual object on the real world. One is smartphone, such as the Pokemon Go, and the other one is wearable glass device, such as HoloLens. So today I focus on the HoloLens. What is HoloLens? HoloLens is introduced in 2015 by Microsoft. As I remember, this is world first untethered standalone glass for mixed reality. And surprisingly, on the device, Windows 10 run. So what functionality HoloLens has? The first one is interaction with object. HoloLens can interact with the virtual object using my hand, and we can pick up the object and we can scale up and rotate, something like that. I can manipulate the object by our hand. The next one is voice control. HoloLens can control the virtual object using your voice command. For example, I say push button. The virtual button pushed without clicking the mouse, for example. The last one is spatial awareness system. Surprisingly, HoloLens can recognize the surrounding environment, such as wall and floor and desk and the other physical objects like that. I also introduced HoloLens, how HoloLens will be applied for the real problem. One is whole anatomy. Whole anatomy allows people to view a detailed 3D model of the human body like that. The whole anatomy helps people, students, to study human anatomy with a high level of detail and interactivity that is revolutionary in the field of medical education. The other case is HoloLens enables doctors to project a 3D model over the patient's body during surgery to bring visibility to organs and viscera that are not easily seen by the naked eye. So HoloLens contributes to the reduction of surgical mistakes. I think HoloLens and mixed reality has a huge potential to solve the unreachable problems like that. So next, okay, HoloLens is very interesting, mixed reality is interesting. So how to set up the development environment? So there are many things. So first one is, of course we need the Windows 10 PC and Windows SDK and Visual Studio to develop our application, because HoloLens app is built as Universal Windows Platform App, what we call UWP. UWP is enabled to use a common Windows API on all devices, including HoloLens. So HoloLens is programmable in C#. The other one is Unity, of course. So Unity is a game engine which gives developers the ability to create 3D games written in C#. So Unity also supports HoloLens and provides a wide range of tools, packages, and resources that make it easy to create HoloLens application to manipulate 3D models. The other one is Mixed Reality Toolkit Framework. So this framework provides many basic components for Unity development. In the following demo, I also used this framework, such as input system, gaze and gesture, spatial awareness system, and speech. The last one is, it is also important, the Windows Device Portal. Using Device Portal, we can remotely control using HoloLens, such as sleep, restart and shut down via Wi-Fi or use USB connection. And also we can capture and save media streams such as video and photo from the HoloLens. And we can show the 3D view page to see how HoloLens visually recognize surrounding environment like that. This 3D model is my apartment room. HoloLens recognize surrounding environment like that. So I want to show how to recognize the HoloLens in this room. So update. horns recognize this room like that. The horns recognize the wall and floor and the other virtual physical object like that. So I move on to the several demo about the functionality of horns. First one is interaction. So how do you interact with whole virtual object? At first, user can gaze the virtual object and air tap to interact with object, and handles the corner and edges of the cube, allow scaling and rotate the object. And also, I implement adding visual feedback to easily understand available input interaction states. By default, the color of virtual object is blue, and if I gaze the object, the color change into the yellow. If I gaze and air tap, the color change into red. So anyway, let's try demo, interaction demo. So capture. Okay. So you can see. Okay. You can see the. Sorry.
It's okay, I turned it off.
Channel my voice. And using verb gesture, I can open the Windows menu like that. Gaze the target and air tap, I can click the object. And I open the Horns application. So take a while to start up my application made by Unity. Come on. Yeah. The virtual object ahead of my vision like that. By default, the color is blue. If I gaze the object, the color is changed. And I can move the virtual object and also tap the corner. I can scaling the virtual object like that. And also click the corner. I can rotate the object like that. So the next demo, voice command. So developer can define any keyword to attach actions. I prepared two voice commands. First one is change. If I say change, change the theme from interaction demo to voice command control demo. And if I say use gravity, adds the gravity to the object and drops the object on the floor. So go to the next demo. So open the application again. Sorry, it's take a little bit time to start. Sorry. Okay. Okay. This is interaction demo. So change. Okay. Move from the interaction demo to speech command demo. Ahead of my vision, there is a virtual object, and also at the basement there is a white plain ground like that. If I use gravity, the object drop the white plate like that. So please guess if I pick and throw away out of the ground, what happened? Hormons recognize the physical world. So, do you think the virtual object put on the wall, or the object drop and disappear? Which one is true? Let's try. I pick up the object and throw away. Oh, what happened? The object is disappeared. the result is different from my explanation in the previous slide. Why? Actually, by default, spatial awareness system is disabled to avoid the visual overhead of calculating and rendering the virtual object. So we need to add the spatial awareness system to our application. The next demo, I add the spatial awareness system to my application. So try the next demo. Okay, so that was close the previous demo. Sorry. Change the beat. Okay, and open the other application about spatial awareness system. Okay, made with Unity. Okay, ahead of my vision there is the object, and you can see the white wire around mine. This is spatial awareness system. If I use gravity. Okay, now the object drop the physical ground like that. So create object. Create cube. Create cube. Okay. Create cube. Create cube. Create cube. Use gravity. Use gravity. Okay. So the virtual objects behave as if this virtual object is physical object like that. Bang. And zero gravity. Now disappears the gravity for the object. So float the object like that. Yeah, it's very interesting. The hormones recognize the surrounding world, and the virtual object behave as if it is the physical object like that. So, in conclusion, the hormones have the functionality of interact with object. So we can manipulate the virtual object using my hand and scaling and rotating like that. And we can also implement the voice command, any voice command, to manipulate object. And finally, surprisingly, HoloLens is recognized the surrounding world, what we call spatial awareness system. So virtual object behave as if it is a physical object like that. So these are reference about how to create the. I use this reference to create my demo, and also I prepared how to set up and create HoloLens app in my GitHub account. I don't enough time to explain all of the things, so I prepared the step-by-step tutorial like that. So if you're interested in the HoloLens and mixed reality, please check this tutorial. So this is my GitHub account and LinkedIn account. So thank you so much for coming today for my presentation.
Hi guys, so thank you for coming to my talk. Today I'm going to be talking about virtual reality. And the reason why I chose this topic is because I think virtual reality is really powerful. Many people know it for video games, but I think it's an excellent tool to improve your memory. It's an excellent tool to that can one day save your life. But before I get into that, I want to introduce myself a little bit. My name's Eugene. I'm from San Diego, California. We're really famous for beaches and burritos. And yeah, that's all you need to know about me. So for the agenda, I'm going to be talking about the history of mainstream VR, and then I'm going to go into the diverse applications of VR, and then I'm going to talk about getting started in VR. So it all started with this scientist named Ivan Sutherland. This is in the 1960s, and he was the first person to ever create a head-mounted display. He had a fairly complicated setup, so they could actually track your head and what angle you're looking at. The actual image itself just produced shapes. So it was really simple, but very groundbreaking at the time. After this, VR was still very primitive, but there was a lot of interest behind the scenes outside of consumerism. So for example, flight simulators, a lot of flight simulators are made out of it. MIT made something similar to a Google Street View, but a more primitive version in Chicago. And NASA also used it for astronaut simulations before they sent people to the moon. And so the first actual real trace of mainstream VR was from this company called Virtuality in 1991. They created VR entertainment stations, and it ranged from whole immersive VR pods to the traditional head-mounted display. And then Nintendo got onto the hype too in 1995. It went terrible for them actually. It was just a disaster. It can only show the color red, and so even compared to the consoles at that time, people were saying how, why would I play this when my home console can show such more complicated graphics, and it was just a general better game experience. So yeah, basically at this point, VR kind of fell off from the mainstream eye, but luckily in 2012, Palmer Luckey revived it with his product, the Oculus. So the Oculus Rift was originally a Kickstarter project, and he actually has extensive background in VR. It wasn't just kind of like, oh, I want to make this VR headset one day. He extensively tinkered with VR, and he had over 300 prototypes that he made before making the Oculus. And ever since then, VR exploded. So there's multiple versions of VR, or multiple headsets of VR. There's the HTC Vive, there's the Google Dayview, and there's the Oculus, as well as many other ones. And so originally, the Oculus was made for games. So what's the current state of VR games, you might ask? And so this is a video game called Beat Saber. It's essentially a rhythm game mixed with Star Wars. And I think it's one of the most popular VR games right now. So this is what the player sees, and then this is what your TV sees. So another really popular one is called Skyrim VR. For those who aren't familiar with Skyrim, it's a like a role-playing game. There's like a fantasy element. There's magic, swords, monsters, dragons, etc. And you can do like really cool things, like cast spells, or just walk around in an environment. You can also pet dogs. It's yeah, what a time to be alive. So, I don't play games. So for some of you who aren't very big on video games, they're like, okay, well I don't play games. Why does this matter to me? Like, why should I be interested in VR? And so I want to ask you, would you want to have the ability to memorize a whole deck of cards in a few minutes? You want to recite pi to the 67,000th place? Or maybe if you're a medical student, you have to learn anatomy, and you want to drastically improve your retention of foreign vocabulary. And so I want to introduce the topic of memory palaces. Has anyone ever heard of memory palaces? Yes? A good amount? Okay, cool. So for those who don't know, memory palaces is basically a memorization technique. It's where you, in your mind, you walk through a really familiar place, and as you walk through that place, you set kind of like landmarks. And it sounds kind of like woo-woo magic stuff, but in actuality, it really does work. A lot of competitive, what do you call them? A lot of competitive memorizers, I guess you can call them, or like memory athletes use this technique. Yeah, and they can do really incredible feats with this. And so there is actually a whole application dedicated to this, to creating your own memory palaces, because one of the key elements of a memory palace is that you have to be intimately familiar with your surroundings, and that means you would have to like go to a lot of places basically, and that can be really difficult for some. So this lets you create your own environment, and you can set even your own little kind of like landmarks with it as well. And there are companies who actually have whole catalog and whole like courses. For example, this is a memory palace layout for Arabic. Okay, so how else could VR impact me? So there's this phrase called education of a knife. Has anyone heard of this one? This one's a little bit more. Okay, cool. So basically, in this book called Complications by a Harvard surgeon and professor, Atul Gawande, he basically talks about the journey of a surgeon. And so surgery is a very complicated process. There's not a lot of constants because the human body is very different and unique. And so even if you're doing the same procedure, things can always go wrong. And someone who is really experienced can still run into things and complications that they've never had before. And so with this, the mantra is best by practice for surgeons, which basically means that a percentage of patients will be victimized for the sake of developing the skills of a surgeon. Every surgeon will have their very first procedure, and things might not always go well, but that's the only way at the moment where they can develop their skills to do such a complicated procedure. And so this is a study conducted, and it shows the general the state of surgeons in the U.S. who are ready to open their own private practice after they finish residency. So it starts from their first year of residency to their 5th year, and by the 5th year of residency, it showed about 25% of surgeons were ready to open their own independent practice, which is honestly a little scary. 1 in 4 surgeons isn't ready. That's kind of alarming. And so there's a whole VR platform called Also VR, which the whole thing is just medical procedures. And with this environment, you can create random variables and variabilities, and so it would most accurately simulate what a real procedure could go like. And this was a study at UCLA, which actually utilized the system. It split a group of 20 medical students into 2. One group went the traditional route, and the other group went with the VR education. And it showed all across the board, the VR group performed much better. And so that brings another question that Atul Gawande brings up in his book called Being Mortal. And he explains how healthcare has done a really great job at elongating the human life, but hasn't done a very good job in the quality of life. So he goes to a lot of retirement homes and he takes a sneak peek into just the life of the elderly, and a lot of them, there's a high rate of kind of deteriorating mental health. There's a loss of autonomy. They feel like they can't really do much or experience as much in life as they did before. And I think VR is a great tool that can really give back a lot of these functionalities, a lot of the autonomy, a lot of the experiences back to these people who are aging. And the last point I want to make is that I think VR is a great opportunity to create communities and foster empathy. There is a program called Virtual VR, and it's basically where you can choose your own model, so you can be like literally anyone, and you just go around and you just talk to people, and it's really accurate. It tracks your facial expressions, and you can track your hand movements. And so for that, I want to show you a quick video.
When my dad was alive, he protected us all the time. He never raised a hand up against me and my sisters. He never touched us. He never did any of that. He was the most kindest man. He's my hero.
I have really long hair up until I did. And when I went into high school, I said, they're gonna be really mean to me. The kids were just rude for us. And everywhere I went, I heard people saying like, are you a boy or a girl?
Yeah, so it's a little odd. Kermit the Frog talking about his troubles. But so it's really interesting when you have a mask of anonymity, but at the same time you're still humanized with your facial expressions and your voice. So this is a person that actually is deaf and signs. And so there's a whole community within VR chat which connects people who are interested in sign language or people who are just people who are deaf to communicate with one another from other deaf people all around the world. And that fine mushroom over there is a man who is suffering from ALS. For those who don't know, ALS is a degenerative disease. So he's basically in a wheelchair and he can't leave his house, but he has VR. So basically in VR he enjoys racing, he enjoys chatting with people, and he just enjoys going on adventures. And these are both made possible with just simply VR. And this is all from a YouTube channel called Seymour. He interviews people randomly in VR if you're interested in that. And so now you might ask, okay, hopefully I piqued your interest a little bit. VR sounds really complicated. It seems like there's a lot of big overhead. How can I get involved? Well, I want to let you know that it's not as hard as you think it is. And I want to demonstrate really quickly how to get started in VR. And so for that, I'm going to be using React 360. React 360 is a framework built by Facebook, and you can trust that Facebook will continue to support it because Facebook also owns Oculus. And so, yeah, it's a good way to get started. It's an abstraction of another popular library called 3JS, but they make it a lot more simpler. So, yeah, without further ado. Okay, so this is just instructions on how to get started. You want to install it globally into your system, and then you just init a new project, and then you yarn start. And from this alone, it gives you the boilerplate for this menu. So yeah, it already creates a 3D environment for you right off the bat. And so these are all the boilerplate files that you're given, and the ones you only really need to be concerned about are the entities where you put your 3D objects. The static assets is where you'll put pictures or videos that you may have. The client JS is where you specify default locations on where you want to render your objects or images. And then your index.js is like you're rendering your images. And so, yeah, this virtual environment seems a little cold, so how about we add a little fireplace? And so this is the code for the whole the fire object. So basically, a entity is a component in React 360 which renders 3D objects, and here we're just calling the entity the React component class, or we're setting a class to extend the React component. We're specifying where our object file is, and our MTL file. The object file is like the shape of the flame, and then the MTL is like the skin, the color of the flame. And then here we're specifying where that we would like to have the flame and the scale of the flame. And then in our client JS, here we are rendering to location of, so basically what we're saying is we're gonna get this fire object and then render it in reference to our default location, which is like a 0, 0, 0 position, like right under you. And the index.js, you just have to register it into the index.js to let it know, like, oh, I want you to render this. And with that, you should have this. Wow. Yeah. And so, let's say you want to add something more, like add some quality entertainment. And so, this is code to get started. So this is the slide I showed earlier. And if you look carefully enough, there is a by default, it's a get render to surface, and that is just a sphere surface you'll see initially when you start up the program. And it's already by default registered. And so here we're creating a function. This is a built-in method that you could create. So you could create the specifications of your video player. And so here we have the asset we're pointing to where or which video that we would like to play. We can add attributes like if it's muted or not, and then you can set the screen size of the video player. And then here, I'm just creating a VR button to call that function when it's clicked. And with that, we should be all good to go. So I want to demonstrate this for you really quick. So this is our nice fireplace. You can look around, and if I hit this play button, Yabai indeed. Okay. And that's it for me. My name's Eugene. This is a deployed version, so you can check it out on your phone. So React 360 is built on top of React Native, so it works on your mobile phone as well. And so feel free to check that out. This is my contact information, and if you have any questions, feel free to come and talk to me after. Thank you so much.
wasn't sure whether I was supposed to wait for it to end or not. Hello everyone. Like, how's everyone feeling? Like, it's been a while. Oh, awesome. That's great, because if somebody said like, nah, like I have to tell them to like stand up, stretch, because we're about to go on what I find like a really awesome adventure into what I like to call the live web. And more specifically, we'll talk about WebSockets that make it possible. My name is Igor, and I will be your guide for today. And first thing first, a little bit about me. So the last 8 years, I've been studying and working mostly in logistics and like energy infrastructure project management. Even like through those years, I've never abandoned like my hobbies, which are pretty much like solving puzzles and like solving problems, like whether they're mine or my friends. And in general, like I really enjoy helping others and like try to make life easier both for myself and for them. And these like last 2 points, they kind of coincided into what resulted in me loving to code and to try and build stuff. And now I want to talk a little bit about why I chose this topic. So to be honest, I kind of feel that lately a lot of people, they don't really like get the awe feeling of something, like when something awesome is happening in front of them. So we're so accustomed that like, oh, this should be cool or I won't use it. Yeah, like, so for example, who knows what this is? Okay, so I see two, I know Mini knows it, so like, this is MIRC. So you can think of it as the grandfather of Slack. And like MIRC wasn't exactly that interactive. Like you actually had to set it up properly. So you had to specify where to connect. You had to specify that give me all the messages available every like 5 seconds or every 10 seconds. And then came this. I'm assuming more people know what this is. I hope. No? Okay, so this is called ICQ. And like this was actually like extremely famous around the 90s. And the reason for it, because this was pretty much the first live app. So you could, I still remember the first time I installed it and like I connected to a friend and I could literally see like, oh my God, like that person is typing a message. And like that's pretty much like a thing that like everybody is like, oh yeah, okay, so there it is, it's written there, like whatever. And that evolved to what we have nowadays, like everybody has like Skype, Messenger and whatnot, like, and so there's a lot of features that are supported there. Like everybody is pretty much using Google Docs these days, but like have you ever wondered how they work? Well, like now I'm gonna try to explain to you using websites. And one thing I want to make clear is that I don't want to say that WebSockets are used everywhere, like in this software. But what I want to say is that you can use WebSockets to replicate that functionality. And to do that, we'll have to go a little bit through like some history. So first we'll need to talk a little bit like what are HTTP requests in general, what are the problems associated with them, and like what problems does the WebSocket solve. And then we'll take a like slightly deeper dive into how WebSockets are started and how they work, and then we'll go into the demo. So without further ado, like pretty much, like I'm gonna assume that like most people know at least like the basics of HTML. If not, the idea behind it is that it always starts with a request from the client that's being sent to the server handles it, like does some processing, and returns a response. So that's like the gist of how it works. If we look back through how this developed, one of the first formats like was HTTP 1.0, and how it always worked is once the browser opens the connection, sorry, not the browser, look, the client opens the connection, it sends a request to the server. So that part is the same. The server does some processing, it sends back a response, like for example a web page that you requested, and at that point the connection was closed because that was like the 90s, dial-up, expensive internet, and like so to avoid unnecessary traffic sending, the browser would not the browser, so like the connection would be terminated. And if we wanted to have like an additional file, we'd have to open a new connection, do the same thing, the connection would close again. And that worked, but each time opening this connection, closing this connection was taxing on the server. So they had to do additional processing for it. And for that reason came HTTP 1.1, which allowed for persistent connections. And what it means is that like once the connection was opened, the client would again send a request, the server would do some processing, send back a response. But at this point, the client could say like, oh hey, by the way, give me that CSS file as well. And the browser would like then return the CSS file. And only like this was possible because like the both the server and the client knew what this meant. So like basically there was a setting that would say that don't close this connection, keep that connection alive. And only once everything was received would the connection be closed. And this works fine. This works great. Like pretty much every, well, not every single page, but like most of the web pages are still using this technology, like this scheme, and there's no problem. But like, would that work with a chat? So like, let's consider how that would look. Yeah. So the client would go like, are there any new messages? The server would look, say no, send back an empty response. Again, like, are there any new messages? And like this kind of back and forth until we get a request like, oh yeah, there's new messages, here you go. And technically, this works. This is pretty much the concept of the MIRC that I mentioned like at the very beginning. But the problem here is that it's not live. Like we need that, like there's always that time delay between each request that happens. Like, and if you make that request too often, the server will get overloaded with requests. If you make that request too infrequently, as in like every 10 seconds, you're kind of missing like the whole feeling of like, so I need to wait 10 seconds, like did somebody write me or not? So like, and the second point is that it's one-sided. I didn't know what picture to use, so I just found a picture of tape. And I hope that's understandable enough. Yeah. And what I mean by one-sided is that it is always initiated from the client. So the server cannot say like, hey, there's new messages, here you go. It always has to wait for the client to send that like, is there anything new? And to solve these two problems, we have WebSockets as one of the solutions. So if you like look into what it means, like they usually see something along the lines of like WebSockets allow you to establish a persistent full duplex connection, and like you might be like, huh? And the idea behind this is simply that like, well, persistent is like pretty much self-explanatory. Yeah, so like using that keep alive, it'll just keep that little connection like without closing it. But what does the full duplex part of it mean? And simply put, it means that we can forget about the request response system. So at that point, it just means that anybody can send messages to anybody. So to make it a little bit more graphical, we have the same vision. Yeah, like so. Interestingly enough, it also starts like very similar to HTTP request. So there's a request to the server gives a response, and if everything is fine, we create a WebSocket, or rather we upgrade to WebSocket. And this is something called the HTTP handshake, which I will explain a little bit later. But after this WebSocket is created is when the, let's call it, magic starts. I really like one explanation that I found on the internet. They literally called it the Wild West begins. Because what happens after this is you can pretty much not think of this as a client and a server anymore. They just become peers. And they are aware of each other and can send messages to each other like at any time. So we can start off with a message from the server to the client. Then we can have a request from the client back to the server, and another one, and another one. So keep in mind that these are not request responses. These are just sent messages, or like data packets. And for example, at some point we might get like just two crossing requests that are executed at the exact same moment in time, literally there is no restraints on like the order or whatnot. And only once one side has had enough and says like that's okay, like that's fine, I don't want to talk to you anymore, is when the connection can be closed. And the best use, so because of that system that they are treated as equals, the best use cases for WebSockets are web chats. They're quite often used for podcasts. Streams might be a bit difficult, so it depends on the type of the stream, but still possible to do. And just in general, getting information, getting live information from the server. So like whether it's like the state of your upload, the state of all the messages, like the state of the database even possibly. And even online gaming, which was a bit surprising for me, because I do want to try maybe someday build a small game using WebSockets, which could be awesome. And okay, let's take a slightly deeper dive into the HTTP handshake that I mentioned, and then we'll finally get to some code. So the key point about the HTTP handshake you need to understand is that essentially it is always still the same HTTP request. So when you try to open a WebSocket, the first thing you send is like pretty much your standard header, but it has one very special point, which is this connection upgrade. So that's like one of the special methods that HTTP supports, but weirdly enough, like pretty much nothing uses them. So like upgrade has been around for I think about like 50 years, not 50, sorry, like 30 years or so, but like WebSockets is pretty much the first thing that like utilizes it properly. There's quite a bit of information that's like, so there's sub-protocols, versions, like I won't go too deep into that. I will talk about this key that you see a little bit later. So in any case, like once this header is sent, that information is being processed on the server, and if everything is fine, the server will send back this, again, very special header, like response code 101, switching protocols. And that means we have a WebSocket connection established. So we'll see how this is happening like in the live code portion. And what I mentioned about the key. So this was actually a very interesting tidbit that I found out. Each time a connection is established, a WebSocket always sends a unique key that it generates. And it always gets back a unique accept key. And the reason for this is because apparently the internet is full of caches. And because this is an HTTP request, if you do not have a unique element in your header, at one point it could just like hit some server. So like normally your request would just get to your web server, get handled, and get the response back to you. But if there's a cache and there's nothing unique in your header, like some cache in the middle might go like, oh wait, this is an HTTP request. I've seen this, I've done this, and just send to you, like send the request directly to the response directly to you without actually transferring your initial request to the final web server. So at that point, your client would think that there's a connection established, but your actual server would have no idea like what's happening. So the request never reached it. So for that reason, WebSockets always send a unique element so that none of the caches can go like, I've seen this already. So that was a very interesting tidbit that I found. Okay, let's go into the live example. And a really cool part of this live example is I will show you how to create like a very simple WebSocket server. And the cool thing is that like it's only 20 lines of code. So like that means it's extremely easy to implement. And usually you'd have like in case of a chat, you'd have like a big front end that like shows everything here and there. But WebSockets are natively supported in pretty much all browsers. So technically you don't even need a front end. You can literally create a client and work through your browser console. And that's what I'm actually going to show in the example. So normally you start off with just creating an HTTP server, and like if people who have created any type of server like know that it's like not difficult. You just like need 3 lines of code, and once you do that, you pretty much like have a server running. So like right now I'm refreshing. We have a request. Okay. The second step is we import the actual WebSocket server package. So that is the only package you need to make this working. And once you do that, you just give the WebSocket server your HTTP server that you just created. The reason we do this is to take care of that handshake process that I just described. Technically, you could implement that whole thing yourself, but it's just easier like to use a predetermined library. And the third step that we need to do is establish that connection. So right now we have a WebSocket server, but we still have no way to deal with the connection. And this is what these lines do. Like, so we just mentioned that like whenever the WebSocket gets a request, do something. And in our case, we just accept this request. So this accept returns to us a connection. And afterwards, like you can do pretty much whatever you want inside. Remember all those like points in the header, like the sub-protocols and like versions? So this is where you could check all of that and restrict that, for example, only accept requests that are this version and like use this sub-protocol. Like, so this is where you would do that. And once you have that, you're good to go. So for example, let's say I add a function that just sends to my current connection the current time and dates like every 5 seconds. Like just a like simple line of code. In the browser, so this is the regular console. Again, the same thing. We just create a WebSocket connection, and we create a message handler. So like whenever we receive a message, do something. And now there is like pretty much like 1, 2, 3, 4, 5. It just works. Like literally, I'm not sending anything to the server. We're just getting data. And pretty much like the next step, so like how to turn this into a chat, is not much harder. We just need to manage the state. So we create a connections array at the very top, and whenever we have a new connection that is accepted, we just push it into the connections array. And on the server side, we just tell it that like whenever the server receives a message, just forward it to all the connections in the array. And like again, if we go back, so these are, so it's a little bit hard to see, but like this is a Google tab, like a Google Chrome interface, and that's like a Firefox there. So again, like we just create one connection and on message handler in Chrome. We create the same thing in Firefox. And let's say we do this dot send hello from Firefox. And you see it appearing here. So that's how easy it is to create it. And like as I promised, okay, technically it's like 22 lines of code, but if you remove the console.info and like do all the arrow functions in one line, that's under 20 lines of code, which is like pretty awesome. Like if you ask me, that like you can literally have like this much functionality in this little time. And if you add some actual front end to it, oh, thank you, Derek. So yeah, you can see like this is actually deployed on Heroku, so I've set up some of my colleagues to send a few messages, and let's say I want to join it. Hello, big MiniConf. And that's it, like pretty much whoever connects to this will see these messages. And technically I did make it responsive, so like if you open it on a phone, it'll restructure itself and will be pretty cool to use. So you're free to use this as well. Just keep in mind that at this moment it does not have persistent storage, but like at least for today, you can all connect and share messages and chat with everyone here. Okay, going back to the presentation. So you might think that like all of this is like really awesome and there's a ton of functionalities, like so we should like use WebSockets for pretty much everything right now. Well, no, because WebSockets also have quite a few like problems associated with them. The biggest pluses that they have is, as I mentioned, they're supported like in pretty much every browser, unless does anybody use Internet Explorer version 9 as their default browser? No? Okay, then you're safe. Because apparently, like up until 9, for some reason, the Internet Explorer did not want to support it. They are insanely fast compared to regular HTTP requests, and this is mostly due to the fact that HTTP requests have a huge like overhead associated with them. So like that header that you send each time, and like if you're sending a small message, usually that means that the header is actually like a lot longer than your real message, and processing that like takes a lot of time. Whereas in case of WebSockets, that header is sent only once, and every message afterwards is pretty much like raw data. Like so, there's like a 2 byte I think header in them, but like still because of that, like because the connection is like persistent and like there's not much processing required, they are extremely fast, and they're very useful in getting just like pretty much any data happening on the server without like making explicit requests. The cons that I mentioned, that I wanted to mention, is that because they start off with a HTTP request, that means you have to have a dedicated HTTP and WebSocket server. So you can, like, if we're talking, for example, like online games, usually they don't use HTTP requests. So like they have their special like sockets created like for game processing. But we cannot just say like, okay, connect to that. Like we need to have an HTTP server to handle that. They are, to be honest, like a bit of a pain to set up if you have load balancers. For example, like deploying the chat app on Heroku was a bit problematic because of the Heroku's load balancer, so you need to do a bit of tinkering. One of the biggest issues with WebSockets is that in case of HTTP requests, you send a request, you get a response, like that's pretty much it. So like the connection is stateless. But in case of WebSockets, the server has to keep track of those connections. So that means like your server is no longer stateless. It has to remember like everybody who's connected. It has to, for example, if you have functionality that sends messages, like it has to remember, okay, so that person's still connected, that person like left, so I can like skip him, that person's still connected. So that makes it very hard to scale. So for example, probably if like 1,000 people connected to my app right now, I'm pretty confident that it will probably crash. Yeah. And in general, like really high volume data transferring is a bit problematic because WebSocket use TCP as their base, and that means that like if one packet gets lost somewhere, pretty much like all the remaining packets will be stalled until you receive that like one lost element. And due to these reasons, usually like when people just like think whether they should use WebSocket or something else, like you would stumble upon like such alternatives as like polling, long polling, server-side events, and these are all valid options. I won't say that like something is better or worse than this, but in some cases WebSockets are still better than like either of these methods. In some cases, for example, you'd maybe prefer server-side events over WebSocket. So what I will tell you is that like carefully consider the actual task that you're aiming to do and choose the right tool for that specific task. Don't just go like, oh, WebSockets are the best, or like, oh, like WebSockets suck, like only server-side events. So like do consider all options. And coming in like with a conclusion, I would have to say that like researching this whole topic was like a really huge challenge for me. Like I needed to understand like all of these details of like how these connections are established, like how everything like works together, and like there was a lot to learn, but I'm really glad that I chose this, and the biggest reason for that is that I'm glad that I learned that like there's this like so much functionality available so easy. Like you just saw like a simple chat app that you can use like pretty much anywhere in the office. Like so you can create a small chat and like maybe secretly chat with your coworkers or something like or friends, like without too much hassle. And that is something that I find like really astounding. And I really encourage you to try it out as well. So thank you very much for coming on this journey with me. I hope you enjoyed it as much as I have. And if you have any questions, I'm available throughout the remaining time. So like, don't hesitate to contact me or like ask questions or like request support or thank you very much.
Hello, hola. How's everyone doing? Good? Thank you for coming. And really quickly, I want to say hola to my mom and dad. ¿Cómo están? Los amo. ¡Mua! Y también a ti, Adrián, y a ti, Leo. Gracias. My friends. So, okay. So today I'm going to talk about Tree.js. And the title of my talk is Holy Shit Tree.js. I chose this name because it's the first reaction that I had the first time I realized the potential that Tree.js affords developers. So let's get started. My name is Victor René Molina Rodriguez. That's hard to remember, so you can just call me Vic. My handle online is CitiusVic, and I come from Chihuahua, Mexico, a town in the north side of Mexico. I'm a musician, and if I look deranged or crazy in that picture, it's because I'm also a developer. I love design, and I do it in my spare time. And I'm a very visual person. I love visuals. I love coding. And I love creating weird and interesting things. So Tree.js is something that brings all of those things together. So what is Tree.js? Tree.js is a JavaScript 3D graphics library. So that means it's 3D for the web. So why 3D? As a creator, as a website owner, as a developer, why do I want 3D in my life? So I have three reasons. The first one is it's visceral. So when we see a 3D image, we are stimulated in a very different way than we just see a 2D image, right? We experience the world in 3 dimensions. So when we see a 3D image, a lot of more stimuli happens in our brain. We can almost feel like we can touch it. And it's very powerful when you use it on a screen. You can turn a logo like this. You could use this for your website. You can turn it into something interesting like this, which I did for my own website. It's engaging, right? This is an example of a website developed by the government of New Zealand. And it's a story about bullying, to teach kids about bullying. But from the first frame, this is how the website welcomes you. It's very engaging already, and it has a lot of depth. This is an actual 3D model, right? The whole story is 3D, is interactive, so it's a much more immersive experience than just a regular storybook or a 2D story told on the web. This is a website for a town called Misatoto. I think it's in Shimane Prefecture, and I really don't have to explain why it's amazing, right? It's a whole journey through the town. It's interactive also, and it's created with 3D. And thirdly, it's just fun. Who doesn't like playing ping pong online? Or manipulating, like putting your hand inside the screen? Or having a portfolio like this, where the parking spaces are links to your GitHub, your Twitter, and things like that. So it's very cool. So now we all believe in 3D, right? We all want 3D in our lives. So before we get initiated in the church of 3D, we need to learn some 3D slang. This is some slang, some of the terms that I may throw around during the talk. So just to be on the same page. A vertex, it's a coordinate in 3D space, right? It's maybe a 3-dimensional vector of x, y, and z. A line or edge is a connection between 2 vertices. A face is a connection between 3 vertices and making up a triangle, which is a primitive in the 3D world. A geometry is a collection of faces. A surface is a description of how those faces interact with light and how it will reflect it or not. And a mesh is a combination between a geometry and a surface. So how is this all possible? Because of some little things called shaders. And a shader is a little program that runs here. Does anybody know what this is? It's a graphics card. It's a GPU, right? A graphics processing unit. A GPU works in a very different way than a CPU works. While a CPU has a few cores and it works in a sequential way, a GPU works in a parallel way, and it has thousands of cores. And all of those cores, all of those threads are running the same program at the same time. So it's very, very fast, but it's very difficult to code for it. because every thread is blind to each other. So every thread cannot communicate with each other, and it's memoryless, so they cannot retain information. So communicating from the CPU to the GPU is kind of like a very, very difficult affair. This is an actual picture of someone who can write shaders. This is what it does to you, so it's very difficult. They're considered some sort of dark art in the programming world. Language that you can use to write shaders is GLSL, which stands for OpenGL Shading Language. And a group called the Chronos Group, which is a consortium of different hardware vendors, they have a standard for it called OpenGL. So it's like an API that people can use and develop the same kind of programs, the same kind of shaders for different kinds of GPUs. So this is an example of a shader. It's generally divided in two parts. The vertex shader is something that will tell your mathematical code, your mathematical idea of your 3D scene. It will translate it into a 2D, right? Because I cannot put my hand through the screen. It has to be translated into a 2D paradigm. Next, you have the fragment shader, and this is where it gets interesting. The fragment shader is the part that runs for every pixel, for every thread in the screen. So the fragment shader tells every pixel what color to be. So let's say I have this image, this wonderful image to start with, and I tell with the fragment shader, I tell the program, okay, ramp up the value of blue by 50. This would happen. So this is a basic overview of the graphics pipeline. We have first our mathematical concept of the 3D thing that we want to render. We run the vertex shader, which translates those things to 2D. It becomes triangles and vertices and primitives. And it goes through a process called rasterization. Rasterization, you may have heard it before, is when those coordinates and those primitives are turned into actual pixels. So now you have a bunch of pixels, and you run the fragment shader to paint those pixels. And after some buffering, you can render something on your screen. So, okay, so I know you're thinking, well, I thought this talk was about 3D for the web. This seems fairly low level. So, yeah, I mean, you don't want to become this guy, right? You don't want to be writing that level code. So the Chronos group actually created another API, a higher level API, that's sitting on top of OpenGL called WebGL. So WebGL is actually a high level JavaScript API for 2D and 3D graphics. So it allows you to manipulate the graphics card with JavaScript. So now JavaScript developers have access to the graphics card, which is pretty amazing. It works through the canvas element. So you instantiate it like this. You instantiate a canvas element with a WebGL context. And we are ready to 3D, right? So now we know JavaScript, we can create cubes and spheres and have a whole scene going, right? Well, kind of. Let's say you want to make this cube. You want to create this cube and render it on screen. This is the amount of code that you will have to write. And this. And this. And this. So, just for this cube, just for this lonely cube, I know you're thinking, oh, well, you said it was high level. Yes, it's high level in relation to the GPU. But in relation to JavaScript development, it's actually really low level. So it's very verbose, and there's a lot of boilerplate that you have to go around with, which means it's a pain in the ass to do simple things. So you're still dealing with shaders, you're still dealing with vectors and matrices, and basically a lot of math, right? And when you're prototyping, when you're a creator, when you want to create things, get them off the ground really quickly, you want to do less of this and more of that. Yeah? You want to get your hands dirty as quick as you can. So 9 years ago, a developer called Mr. Do. I forgot. Ricardo Cabello. Yeah. His name is Ricardo Cabello. His handle is Mr. Do. He created something called 3JS. And 3JS is another layer of abstraction over WebGL and OpenGL. So now let's say you want to create the same cube again with 3JS. This is all you have to do. So it all fits really nicely in our screen, and it's bigger font, right? So for 3JS, there's a few concepts that we have to understand. First, you have a scene, which is like a stage where your play is going to pan out, where you're going to put your objects. You create a camera, so that's like a representation of how the user will see it. The renderer is like a painter that decides which way to paint things in the end. The geometries that you want to put, like a cube, like a sphere, like whatever you want. Materials, which are like the surfaces, right? And when you mix the geometries and the materials, you have your meshes. And also lights. So it feels very high level now. It's almost like being a movie director, where you just put your different things on your scene and you create them. So just to go over it really quickly, here we're creating the scene, then the camera, and then we're giving some parameters as the depth of field or the aspect ratio. You create the renderer, you give it some configuration like transparent backgrounds or smooth edges for the lines. You give a size to the renderer, you instantiate your geometries. In this case, we're instantiating a cube, and we give it the dimensions 1, 1, 1. You create your material. In this case, we are using something called a normal material. In 3JS, you don't need a light to see this material. If we were to use a different kind of material, maybe we would have to add a light in order to see it. I cannot tell you how many hours I've spent looking at black screens because I forget to add my lights to my scene. You create the cube, mixing the geometry and the material. You add it to the scene, and then you can animate it. So you have a loop here, which is requesting a frame every 60 seconds. Every 60 times per second, roughly. And you can make your transformations here. For example, we're rotating the cube in the X and the Y axis. And then don't forget to initialize it. So now value binding is very easy. We have all of these variables here that we can manipulate. And we can create interactive things like this for the web. So I'll show you a little demo. This is an application that I developed 2 weeks ago called Planetarium. And it's an app for visualizing planets. It's very simple. It took me 2 days to make. And that's not a testament to how good I am at coding. It's a testament to the power of 3JS. So, like I said, data binding is really easy. You can change the values of the camera. You can change the position of the lights. And you can change the rotation speed. And because I wanted my app to be inclusive, I created this version too. It has a lot of other planets. Like Saturn, this is actually 3D objects. It's a ring geometry here, 2 rings, and they're bound to the main sphere. So the one I like the most is actually Mars. Let's see if it loads. Yeah. For Mars and Mercury, I added another texture which tells the sphere where the valleys and the mountains are. So it actually, the light reflected actually interacts with those valleys and creates shadows. So I think that's pretty cool. Oh, you don't want to see that? So for another demo, this is another thing that you can make with 3JS. So this is another story that I really like. And it's an immersive story, right? So when you scroll down, you can read the story and interact with it. And the events that happen actually happen on screen. This is done with 3JS. Also, you can create things like this, which is a website, a portfolio for a filmmaker called Tao Tajima. He's using shaders and 3JS to create this effect where you can scroll and see his different works. And this is impossible to do with just regular HTML, CSS. So I thought it was pretty cool. Okay, so how to get started with 3JS? Luckily, it's very easy to get started. The 3JS docs are very powerful. So I'll show you. You go to 3js.org, you go to the documentation, and really off the bat you can learn how to create a scene. There's code examples. And let's say we want to create a sphere. So It gives you an example of how your sphere would be rendered on screen. Also a code example. And look at this, it's just 3 lines of code. So with 3 lines of code, you can put a sphere on your website. It also gives you the option to configure several of the variables. For example, I want it to be bigger or have more width segments, height segments, anything. It's also full of really cool examples. So the example section has a bunch of examples that you can play with, and you can always see the code if you click this button. And for example, you're thinking about adding lights to your scene. So I look for lights. And you can see live examples of how the light would interact, the different kinds of lights that you have, and how they cast shadows on your objects and stuff like that. You have geometries. You can see all the kinds of basic geometries that you can render to your screen. And also, there's a wide range of post-processing effects. So when you're done with your scene, you can actually add some more layers or some more effects to make it look more cinematic. And yeah, there's a bunch of things you can do. It's very powerful too. So this is all code that's running directly on the GPU. So we can have many shapes, many constructs on the screen at the same time. And you see my computer is not even complaining at all. So, okay. Another good resource that you can check out is a book called Discover 3JS. It's an upcoming book. It's not finished, but you can access the first 2 chapters right here. And they're a very good launch pad for you to get started and understand, even if you're new to JavaScript, even if you don't know a lot about JavaScript. So yeah, I recommend you check this page. And if you're still not convinced about 3D, if you still don't feel like implementing 3D in your life, I have something, some last thing to show you. Like I said, 3D is engaging, it's visceral, very visceral, and it's fun. So thank you.
Okay. Thank you so much. That was beautiful. So with that, this concludes session B of Big MiniConf. I want to invite everyone to demo day. So a lot of the things and projects